Hi everyone, I'm back for another video. Now, let's discuss about tree data structure. So, introduction to tree. So, a tree is a finite non-empty set of elements. It is an abstract model of hierarchical structure, consists of nodes with a parent-child relation. So, it also applied for organization charts, file systems, and programming environments. So, if we talk about tree, so this kind of tree here, a computer science view tree. So as you can see, it is an abstract of hierarchical structure. It means that may hagdan-hagdan. Ayun, may pagkahagdan-hagdan ang model. And then it is also may hangganan na tree because it is a finite and a non-empty set. So it means that may mga data within this tree. So this kind of tree is useful for organization, for to have that clean and organized charts. So this is what I'm saying. It is this kind of tree here is the nature view of a tree. This is an original tree. As you can see, the root is in the bottom and the leaves are on the top. While in computer science view, it is in the opposite because the root is on the top while the leaves is on the bottom. This is how the computer science or this is how our tree of data structure will gonna be like that the roots is on the top while the leaves is on the bottom. Learning about tree data structure, we need to know the basic terminologies in this tree. So we have this root. Root is the node without parent. So basically understandable, right? It is a node. Okay, before anything else, I would like to say that this part, as you can see, the A here, the C, all of this in a circle is what you call a node. And this A, B, and this alphabetical here are called the data. So this data is inside a node. And just like a form or a structure of a tree, kasi naghahagdan-hagdan. So, ang root, di ba sabi ko kanina, here, a computer science root is on the top while the leaves are on the bottom. So, in this example right here, as you can see, the root is on the top, which is the A. The root is without the parent. So, basically, she's the mother of all. Wala siyang ancestors. So next is siblings. Siblings nodes share the same parent. So understandable, they have same parent. So we have here example is the D and E. They're called siblings because they have one parent, which is B. Another example about siblings is M and N, which is they have same parent, which is the I node. Next, we have here the internal node, a node with at least one child. So it doesn't mean na need lang na specific one child, but at least it means that either one or many. So example of this is A. Since A node, let's say A node have two children, which is B and C, and internal nodes are the nodes with at least one child. And A is pasok doon kasi let's say she have children, which is C, B, and C. And then another example is D. D node have a child which is C, H. And then let's hop into external node which is the leaf. So external node, those are pinakababa. Yun yung ito. Yun yung mga leaves. Kasi 'di ba sa computer science view, yun ang pinakababa ay yung mga dahon, mga leaves. So the external node are here. The K, L, M, and OP because wala na silang mga children. So, sila node without children. Wala na silang mga children. Sila na yung pinakahuli. That is called the external node or the leaf. Next, we have the ancestor of a node, the parent, grandparent, and grand-grandparent. So let's say we have here the ABA are the ancestors node of the node I. It means that, okay, let's say here, if for example, I have I node here. So what is the ancestor of the data I? It is the E, B, and A. Why? Because I data or the I node have parent name E and E and E node have here her parent called B and B have parent which is CA. So from 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 I parent to the grandparent to the grand-grandparent. That is ancestor. Kanuno-nunuan. And then we have also here, okay, another example for ancestor. So we have here, let's say, what is the ancestor of P? So, the ancestor or ang kanununuan ng P na node is J, F, C, and A. So now let's hop into another term which is the descendants of a node. It is the child, grandchild, and grand-grandchild. Diba kanina, where we tackled the ancestor which is the ninuno. Ngayon, ito naman yung mga inaapo. So, example here is the D and H node are the descendants of the node B. So, it means that the node B is ang mga anak niya at mga kaapu-apuhan is the D, H, and K. Diba? So, now, another one. Let's have this dip of a node. So, the number of ancestors. So, the number of ancestors. So, ano ba? Ilan ang mga ninuno. So, let's have an example. Let's say I have here the G. What are the number of ancestor of node G? So, we have here the C and A. Diba? Kanununuan. So, we have two ancestors. So, the height of a tree, maximum depth of any node. So, the height here, as you can see in the picture, the height of the tree. We have here the 1, 2, 3, and 4. Diba? Ano kasi yan eh, pang branch, diba? Kung i-visualize natin, it's from the root. As you can see, it's from the root. From the root, we have the sub trees, which is the branches until sa last branch, except to the leaves. Kasi hindi naman siya branch. And then, so in this part, we have here the height of the tree, it's because, as you can see in the picture, the height of the tree is count in this level from level 0 in the root 0, 1, 2, 3, and 4. So, until 4, yun yung height of our tree. Next is the degree of a node, the number of its children. So, for example, we have here the number of the number of children of node B. So we have here node B. Number of children, we have 2 because the only children of node B is D and E. That is the degree of node. So the next is the degree of a tree. So the maximum number of its node. So the degree of the tree is the maximum number of its node. For example, the maximum number of its node in this particular example is 2 only because, as you can see, let's say the A or the root, the A node have only 2 children, while the B have only 2 children also, and then the H have 2 children also. So the number or the maximum children or the maximum number of its node only 2. So the answer is 2 in this example. Next is the subtree, tree consisting of a node and its descendants. So kanina, as you can see here, so the tree consisting of a node and its descendants. Descendants, di ba yung mga inaapo? So here, from A, diba, as you can see, the triangle here, as you can see, this is what we call subtree because nandito yung inaapo, which is si D, and yung anak, which is si D, ay si B, si D yung inaapo. Descendants, and descendants na kasi to ni din. B is a child of A and also a descendants. Next is the edge, connecting lines of a tree. So as you can see here, we have here the edge connecting two nodes. That's what we call edge. Next, here is the representation of tree data structure. So we have here the root nodes. Ito yung talaga constructor of a tree, yung walang laman. Kasi kanina, di ba? As you can see, may mga laman na ng mga data, which is the alphabet. But in here, in this example, walang laman. So here, as you can see, we have the root, which is, di ba? As what I've said kanina, the root is on the top, while the sub of tree, yung mga anak na niya, yung mga descendants, is nasa baba. Next, we have here this one. So another example. So here the number of nodes of this particular example. Number of nodes. What is the number of nodes again? What are nodes again? This one, the box or the square here are called nodes. Nodes yung walang laman, diba? But in here, in this picture, may mga data na nakalaan in every node. So let's count the nodes. We have A, B. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of node of this specific image or the specific example is 9. Then we have here the height. We have 1, 2, 3, and 4. That is how you get the height. So we have here the root node. The root node, as what I've said, yung walang ancestor. and walang parent, walang ancestor. So we have here the A, and then the leaves. Leaves are the external, what do you call it? External node. The external node here, or the leaves are, we have yung wala nang magmamana, or sila na yung last. So we have here the D. We have here, let's have this first. We have the C, D, F, H, and I. Next, we have the interior nodes, yung may mga anak branches. So we have here the A, B, E, and G. Excuse me. And then we also have the ancestor. Okay, it is another example for an ancestor. The question is, what is the ancestors of H? This is the H, node H. So the ancestor of H is G, E, B, and A. Right? And then the descendants of B. This is B, descendants. Descendants is yung mga kaapu-apuhan. So we have here the E, G, H, and I. So next, we have here siblings of E. Siblings only have the same, or only have one parent, same parent. That's it. So siblings of E is D and F. Next, we have the right subtree of A. The right subtree of A. Here, the right subtree of A, the descendants of A is C. Then next, we have this degree of this tree. The degree of this tree is, is 3 because, as you can see, the maximum of nodes na nandito is 3. We have, as you can see, the A have only 2, the B only 2 children, then B have 3, then E have 1, and G have 2. So the maximum is 3, which is naandon kang B. Nodes niya is 3. The degree of this tree is 3. So now let's talk about types of trees. So we have here 5 different trees. So first, let's tackle the general tree. So if no constraint or rule is placed on a tree hierarchy, a tree is called a general tree. Every node may have infinite numbers of children in general tree. The tree is the superset of all other trees. So, in general tree, pwedeng maraming children and uh, ancestors. Yun. And wala siyang rule kasi yun nga, it's called a general tree. So the second one is the binary tree. The binary tree is the kind of tree in which most 2 children can be found for each parent. The kids are known as the left kid and the right kid. So this binary tree is a kind of tree wherein it has a 2 children known as the left kid and the right kid. But no worries, we will tackle deeper into binary tree. Anyway, binary search tree. So binary search tree is a binary tree extension with several optional restrictions. The left child value of a node should be BST be less than or equal to the parent value, and the right child value should always be greater or equal to the parent's value. So I have here some examples so kanina we tackle about the general tree. As I've said earlier, it has no rule and could have many children. So as you can see the image here, walang Wala siyang rule, walang kahit ano ang sa general tree. It's just this structure. And then we have here the binary tree. The binary tree have, as what I've said kanina, it have children that consists of two only. As you can see here, their root have only two children, and the ancestor, uh, the ancestor is the one, right? And the descendants of 2 and 3 is only two nodes. That is binary tree. And then the binary search tree, the definition itself said that the left side node of this tree would always be less than to the value of the root. So less than. So as you can see, 15 is less than to 45. And then the right should always higher than the root value. So 79 is the value of our right. And it is bigger to our 45 root. So another here. So we have, so okay, let's say we have the 79. So the left of 79 is lesser to its value of the root, while the right side of the child of 79 is higher than the parent, which is 79. That's how binary search tree works. So we have here AVL3. So AVL3 is a binary search tree self-balancing on behalf of the investors Adelson, Velchi, and Landis. The name AVL is given. It was the first tree that balanced dynamically. A balancing factor is allocated for each node in the AVL tree based on whether the tree is balanced or not. The height of the node kids is at most 1 AVL vine. In the AVL tree, the correct balance factor is 1, 0, and -1. If the tree has a new node, it will be rotated to ensure that it is balanced. It will be rotated. So here is the example of the AVL tree. So it is a self-balancing tree, kind of tree, the self-balancing. And then last but not the least, we have the splay tree. A splay tree is a self-balancing also, same as AVL tree. What makes the splay tree unique is the extra property that is splaying. So a splay tree contains the same operation as a binary search tree, insertion, deletion, searching, but it also contains one more operation. That is splaying. So all the operation in the splay tree are followed by splaying. So here is an example of mine in the splay tree. Here it is. It's also a one balancing tree, just like AVL tree. So next is binary tree. So a binary tree is a tree with the following properties. So each internal node has at most two children. The children of a node are unordered paired. We call the children on an internal node left kid or right kid or right child. Alternative recursive definition is a binary tree is either a tree consisting of a single node or a tree whose root has an ordered pair of children, each of which is a binary tree. So, ang binary tree, di ba, I have here an example. We have two pictures for comparing the general tree and a binary tree. So as you can see sa general tree or a tree, maraming anak-anak, maraming children, and it's not a ordered pair. So in binary tree, as you can see, it is called ordered pair kasi yung pinaka-top pa lang may may format na. As you can see, the A the nude A children is only 2 and the B's children is only 2. It is an ordered pair. And these two children of them is called left child and right child. So the D here, as you can see in the picture, the D here is the left child and the E here is the right child of this binary tree. So this tree, a binary tree could also consist a single node. So binary tree, this is an example. So node 1 is the root because 1 has no parent, and 2 and 3, this one, 2 and 3 is our siblings and children of root 1. And 4, 5, 6, and 7 is the external nodes. And 1 and 2 of 5. So if we look at here, the 1 and 2 are the ancestor of node 5. This image is also an example of a binary tree, a paired binary tree. Kasi, as you can see, the node 1 or the root have only 2 children. And also the node, the ancestor of their children only consist of 2 children. Then we have the binary tree traversal. So a tree traversal is a specific order in which to trace the nodes of a tree. There are 3 common tree traversal. So in order, which is from left, root, and to right. Then we have here also the pre-order from root, left to right, and last is post-order is from left, right, and root. So for in order, we must print each subtree's left branch before we print its root. So note, pre and post refer to when we visit the root. So anyway, we have example for this. So for today guys, we will be having the flow of the binary tree traversal. So first, we're going to have the pre-order, which is from root, left to right. So first, we need the blue color here is for the pre-order. The green dot here is for the in order, and last is red for the post order. So this is the flow of the traversals. So we need to have this pre-order. So pre-order from root, which is the A, then go to the left, B, tapos D, and then after the D, you have H, I, and then E. After the E, we have C, F, G, and J. That is for the pre-order. From root until the left and last for the right. Next, we have the in order. The in order is the dot green. So we have here the in order is from left, root, and to right. So we have here H kasi first yung left. So H, D, I, B, E, tsaka pagkatapos ng left, put tayo sa root, which is A, and then to right, F, C, G, J, until G. And then last is the post order. The post order is the left, right, and then last is root. So the red dot is the post order. We have H, I, K, kasi from left kasi H, I, D, E, and saka B. Tapos tapos pagkatapos ng left, right tayo, we have F, J, G, C, tapos yung last is yung root. So, this is the pattern of the traversal. So now, let's do some exercises. Let's answer this one. First, we have the in order from left, root, and right. So, what I said kanina, di ba? Let's all print the left first bago tayo pupunta sa root and then to right. So, let's have, yung pinaka-left talaga, di ba? As you can see, is the 3. So, we put the 3. Next, we put the 5. Kasi left siya. And then, punta tayo dito. 6. Then, ubusin na natin. Dito na tayo sa 7. And then, we have here 10. And then, pagkatapos sa 10, we have 12. And then, 13. And then, now that we all type the left part, now we go to the root. The root is 15. So, we put 15. And then, pupunta tayo sa right. So, yung right is 16. Then, 18. 18 kasi, nun pa left kasi siya. And then, we have 20. And then, 23. That's how it works in order. Next, we have pre-order from root, left, tsaka right. So, we have the root, 15. Next is the left. Left is from 5. Pababa na naman tayo. We have 5. 3. And then, punta tayo sa pinakababa talaga para paakyat na naman. We have, pupunta na naman tayo dito. We have 12. Pagkatapos sa 12, we have 10. And then, have 10. And then 6. And then 7. Pagkatapos sa 7, we have 13. Pagkatapos natin sa left, we go to right. Dito sa right, we have 16. And then 20. And then 18. Tsaka 23. That's it. That is how you going to answer or trace a pre-order. Then last, we have the post order. It's from left, right, and to root. So we have pinaka-left, we have 3. And then punta tayo sa pinaka-baba. We have 7. And then paakyat tayo. 6, 10, and then 13. Pagkatapos sa 13, we have 12. And then 5. And then right, punta tayo sa right. Pagkatapos ng right is root. So, ang right natin ngayon is 18. 23. Paakyat kasi to eh. Kasi yung root nasa pinaka-baba. So, paakyat ang tracing natin. So, 23. And then 20. Pa, diba? Ganito yung tracing kanina. From 3, ito tayo sa 7. 7, then tayo sa 6, 10, 13, 12, 5. Pagkatapos, dahil left, tapos tayo sa left, punta tayo sa right. Then punta tayo sa 18, 23, 20, plus 16. And then, last, dito, the root, we have the 15. That's it. That's how you're going to trace a traversal and binary tree. This is the flow of making a tree balance. So, next, this is how it works. So, that's it. That's it for our topic. So, thank you guys and see you on my next one. Bye.